working a lot on the intake subsystem and the indexer subsystem. So just a quick overview of both. So for the intake subsystem, we really didn't want to have to deal with the complexities that come with bringing a mechanism out of frame. We only got 30 hours, so sometimes you got to cut features. So what we've decided to do for that is use 2 car wash rollers, which is just surgical tubing zip tied around a log axle, and a passive polycarbonate ramp that singulates into the side of the robot that leads into the J-hopper. So instead of having to deal with either a tiny intake that only picks up at one point, or a full width intake that you have to singulate inside an open hopper, we're taking kind of a cheeky approach, for lack of a better word, and just vectoring it along a polycarbonate ramp before it hits our hopper. In terms of the hopper, what we didn't want to do for our hopper was stack them kind of like a Pez dispenser, like you saw a lot of teams do in 2013 with other Frisbee games, or in FRC, I guess, my bad. So what we decided on doing was a J-hopper, so we could still fit all the Frisbees in a line and have room for a shooter mechanism. It was a big debate between the J-hopper and just a linear hopper, where all 3 rings are right behind one another, but because a linear hopper wouldn't afford us any room for our shooting subsystem, we decided to go for the J-hopper, so we had a lot more freedom with what we put up here. The J-hoppers evolved a bit over the course of the day. It started out with polycord rollers all along here, and with a split in the middle, so you could actually take rings without affecting the rest of the group. But as concepts have kind of come to fruition, and we've realized that Luke will talk about later with the shooter, that a spring-loaded shooter may not be the best or simplest solution, I should rather say. It's evolved into a short polycord belt to take it from the intake and a central wheel to wrap them around the J-hopper into the flywheel shooter. So development goes strong. That's all I've got for you.
Hey guys, so on the topic of the shooter, at first we were kind of thinking something along the lines of a kicker or a launcher that would use probably some potential energy and be able to kind of just send the ring forward at a controlled angle, and that was going well at first, but we kind of came to some different road bumps, so we started putting some more time into the flywheel design. So right here we have a 20-to-1 never rest motor, and it has a 1-to-27 total compound gear ratio going upward for speed, and it rotates pretty fast. I think we said about 9,000 RPM at the wheel, theoretically, with no load.
Whoa, look at this. 3 for 4. 4 for 5. 5 for 6. 6 for 7.
For our mechanism for the wobble, we have this, I think. So it's got the V to kind of lead in, so you don't have to be as accurate when you're hitting it. And then it comes down this part and it gets stuck, so like the little ridge here, so it sits in here kind of nicely. It's pretty in there. So with this, there's a couple different things we're looking at for how we're going to get it outside of the field. And so yeah. Okay, so we were working on moving the wobble from the field to outside the field. And so at first we tried moving it just like rotating it this way and then moving it outside the field and rotating it back down. But the issue with that was from this, from grabbing it under this little lip and then by turning it, you wouldn't completely clear the wall. So you would have to angle it higher, but the issue with that is then the rings, if you had multiple rings on, it would get in the way, or you kind of had to just drop it, and then that could be against the rules. So we decided against that.
And so our alternative to that is now using a drawer slide, so it'll bring it up, plus we'll have a piece of Tetrix that is acting as a gap to clear the wall, and we'll have this piece of rail, the Rev extrusion. So then we'll have the grip. We're gonna still use the same grip that we were using for the wobble, but because that was just an easy, quick clip grip, you could say. And so when you lift this up, then you would drive over, so then you will be able to lower it down and then be able to drop that off by just backing up the robot. So yeah.
So with our J-Hopper design, we knew that we'd have to get really close to the game field. The problem with that is, if you see on the back side how the Outrunner chassis is normally set up, that's going to create a very steep angle. So in order to give ourselves a little bit more room, we took out the top support bar for the front, as well as filed down the inside here, so that way we can do a plate that extends from here at a much less of a steep incline, allowing us to more easily push the discs up into our J-Hopper.
Alright, so in the programming world, we currently today finished getting our setup all set up. That's kind of a fun. So we were able to pair the two phones together, and we're able to control a motor with our Logitech controller, so we're going to expand on that obviously tomorrow to get the robot to move. We're also doing some stuff with OpenCV. We are currently working on detecting these rings. The basic goal of that is to, if the rings are stacked up, we're able to detect the contour lines of the rings and then draw a box around them, and then we should be able to count the rings that are in a stack, and that will help us during autonomous and during. So we're filtering out the hue, saturation, and value of these rings here, and then we're able to take this, they call it a binary image, and we're able to take out the contours, which is kind of like the outline of the disc, and yeah, that's basically it. The next step after this is to put a bounding box, if I can get a good contour position, it would be to get a good bounding box around these, so we would be able to count them when they're stacked.
Hey guys, it's Jesse. Programming update. We are working on finishing up teleop code, and I'm beginning writing autonomous code now.
You don't see what we see, you're your own enemy.